Hi, Professor, and this is Nikhil, and today I'm going to present my a final project that is hand gesture recognition. My teammates are Naga, Praveen, and Govardhan, Reddy, Illuru. These are the contents of our project. So we have the abstract, introduction, data set review, and data set, and, and final the results and the software requirements of this project. So coming to the abstract, so basically we humans we communicate with each other like using our verbal mode of communication, but here I designed a model which is used to convey using the non-verbal way of communication. So that includes the gestures mainly. So the gestures are from the hands. So in this project, uh, it designs like it predicts the model. The model predicts the gesture of the human, and then it gives the output, and then the output will be transferred as a mp3 file, so you can listen the output. Like if you there is a word like two or three, it will be in a mp3 format. And the hand gestures are they are the most effective communication tool and most commonly used in the gesture system. Hand recognition may be recognized using one of the two techniques, like the posture, like a static hand form, or else a gesture like dynamic, so moving the fingers or else moving the hands. And then using any form of camera will detect any form of the hand gestures. So most finger movements may be detected by two-dimensional cameras in continuous surface as a 2D plot. And then coming to the introduction of our project, the sign language is a language that employs sign made by moving the hands and combined with facial expressions and postures of the body. So it is one of the most several used communication system in our uh, like for the deaf or hard of hearing people. So gesture language identification is one of the areas being explored to help the deaf integrate into the community and has a high applicability. So we use the CNN, and then for the recognizing of the gestures like a convolutional neural network, we used it, and then identify many complex gestures, and we have a big vast data set. So coming to the literature review, so we have this data acquisition and pre-processing, representation, and feature extraction. The feature extraction includes extracting the feature from the gestures like the letters like A, B, C, and all up to Z, and then the numbers, all this stuff. And then after that, we classified the data which was got from the gestures, the painting. So these are some of the journals or the papers published by some of the uh, like in the websites like Journal of Image and Graphics and Journal of Image and Graphics and I3V Explore. So some of the I took it from the data set. So they are working on artificial intelligence, but I use CNN for the output. And then this is the proposal method. So here we have the image processing technique, and then feature extraction, and then training and testing the data, and then finally the output, which gives output like it gestures like it. And then in our project we use as I mentioned before, we use a convolutional neural network, and then certain prime channels of VGG16, inspection V3, and then OpenCV functions to the OpenCV is used for mainly what you said, GUI based things like the camera, all this stuff, and then the computer vision for hand gesture recognition. And then the images are I took the in the data set are in the JPG format, and the JF format. And here you can see, like I'm going to explain what is the CNN. So here you can see there is an eight letter over here. So basically the CNN is a matrix representation. So the 8 is divided like it is equally partitioned in the boxes of the matrix, and then whether if we have the data in the box, so it will be represented at 1 or else 0. So all the ones you can see they are in the 8 shape. So digit 8 represented in the form of 0 or 1 pixels. So and then the convolute and the grid like structure is processed in a convolute. And then the transfer learning, I used VGG16. So VGG16 is a pre-trained model which has 14 million image datasets belonging to 1,000 different classes in ImageNet. So here you can see the pre-trained deep features and the trained data, text data, and the deep neural network, and I have the accuracy and all the stuff in it, the reference score and the recall precision. So the dataset. So coming to the dataset, the dataset source is from the Kaggle. So it has a nearly 14,000 samples of the data, and then all are the your images, and then these are some of the examples for it. So you can see it's nan means like this, and the one and two, C, I, and all the stuff over here. This is about the dataset, and then implementation. So as I previously mentioned, I used the CNN for the implementation, and I also used the CV2 PyQt and NumPy for working on numerous, and then Keras Matplotlib for the what is it, the graphs and all the stuff, and the TensorFlow. And the input size of the image is 256 into 256 into 1, as image is a grayscale image because it's not a colored image. It's a grayscale, so it's 256 into 256 into 1. And then the max pooling layers reduces the size of the image, that we can less the number of computations and speed up the model training process. And we have used data augmentation for CNN model, as the data which we have the limited numbers of data set, but these data cannot be sufficient for training and detecting the features from the gestures. So I just replicated the data using the data augmentation. And as I mentioned before, the VGG, it has 14 it is you can see the VGG the input, and then the input is passed all these layers every time, and then the final output will be here. So it has a 16, 256 into 1, and then the normal image size is 224 into 224 into 3. So and we are not even training all the layers of the VGG16, and we have set the layers trainable to false, so we can only train few layers. If I set it true, it goes on training every single layer, but I set it false, so I can just make it learn from only some of the layers and then freeze it. And implementation of OpenCV Geo functions. So OpenCV, as I mentioned before, it is used for the Geo applications and the video capture. So which is used to capture the video of the user, and then guess the gesture made by it. And CV2 color, it is used to convert the colored image into grayscale image. So and these are the things I use from OpenCV and the Geo functions. And the results I will show you the next coming. And these are the some of the plots which are like from my data. And then you can see the training loss and accuracy, and the echoes and loss and epochs. And the software requirements are operating system Windows 10 plus and Python 3.8 with the TensorFlow 1.14, and now the TensorFlow is 2.21, and then GFMF is PyQ25, and Pandas and Matplotlib Pascal are not for the plots and all the other things like converting the data, reading the data set, all these things. So the conclusion, so the basically my project is mainly based on guessing the gestures by capturing the video. We use the CNN and VGG16 for it. And so now I'm going to, these are the some of the references I have to while doing this project. And then that's it. And now I'm going to share my the data set and the what is the working code. So here you can see this is the data set, and have the test data, and this is a different follow for different letters and the numbers. So for example, if you take K, these are the images of K, like this is the K symbol. And then they are coming to the A, and we have separate data set for A, and for the B, C, everything, like all are JPG format images. This is the A. And then coming to my normal files, and these are the files I have. These are the models created by model. I cannot run the model because it takes more time for training it again and again. So this is my code, and I'm running my code here. And then this is my model, Keras model. I'm running it, and you can see these are the labels for my data. And then coming to my code, and this is my final code. So while running this, I will get an output from Python CV2, and a window which is taking the camera output. Again, you can see there are two outputs. One is grayscale, one is a raw image. In the raw image, I will show the gestures, and then it guess the gesture. The model predicts the gesture, and then you can see its count is 1 and 2 because I showed two gestures to the system, and then now it is the third one, and this is the this is the letter N, and it is guessed like N, and that's it. And this is my project. Thank you.